Target 8.5, I can calculate the molecular formula of a compound. In the previous video, Target 8.4, we learned how to calculate the empirical formula. Now I'm going to add steps to that to show you how to calculate the molecular formula from the empirical formula. Here are the steps. First, find the molar mass of the empirical formula, then compare it to the molar mass given in the problem. If it is the same, then you're finished. That means that the empirical formula and the molecular formula are the same. If not, then divide the given molar mass, the one given in the problem, by the one you calculated. You should get a whole number here. If not, you probably should check your math. Once you've divided and you've gotten a whole number, then you'll multiply your empirical formula subscripts by the number that you got. Alright, I'm going to show you how to use these steps. Here's your sample problem. Find the molecular formula of a compound that contains 30.45 grams of nitrogen and 69.55 grams of oxygen if the compound has a molar mass of 92.02. So I've written all your given information here. 30.45 grams of nitrogen, 69.55 grams of oxygen. Also given that the molar mass is 92.02. All of this is given in the problem. So now we'll go through the steps. Here are the steps written here. Change the grams to moles. First we're finding the empirical formula. So we're going to change all the grams to moles. So 30.45 grams of nitrogen, 14 grams of nitrogen in 1 mole of nitrogen. Once we divide that, it comes out to 2.175. I left my decimal out there. Moles of N. Let's fix that. 2.175 moles of N. Do the same thing with the 69.55 grams of oxygen. 16 grams of oxygen in 1 mole. When you divide that, you get 4.346 moles of oxygen. Now, the next step for finding empirical formula tells you to divide by the smallest number of moles. 2.175 is smaller than 4.346. So I will divide 2.175 by itself, and that comes out to 1, which I've done here, divide by the smallest. Do the same thing here, divide this one by the smallest, which is 2.175. And when you do that, it comes out to 2. So in this case, when you divide by the smallest, they all came out to a whole number, so I do not need to multiply by anything. So I already have my empirical formula. It's 1 mole of N and 2 moles of O. So the empirical formula is NO2. Now, I have my empirical formula. I have to go back up to the problem and see what the molar mass of the molecular formula is. The molar mass of the molecular formula is 92.02. I'm going to find the molar mass of the empirical formula, compare it to the molecular formula. If they're the same, then I stop because this is the molecular formula. But when I compare it and if they are different, then I have to do a couple more steps. So let's go ahead and do that. Let's find the molar mass of NO2. NO2. Well, it has 1 nitrogen. Nitrogen has a molar mass of 14. It has 2 oxygens. Oxygen has a molar mass of 16. So that's 32. 46 grams per mole of NO2. That is not the same as 92.02 given in the problem. 92.02. So the given molar mass was 92.02 and my empirical molar mass was 46. So divide the given molar mass by the empirical molar mass. 92.02 divided by 46 gives me 2. Very close to a whole number, close enough to round. That tells me that my empirical formula needs to be multiplied by 2. So multiply the empirical formula by the number you got in step 5. I got 2. Multiply by NO2 gives me N2O4. N2O4 is your molecular formula.